Next example, 5 dice were thrown 96 times and the number of times an odd number actually turned out in the experiment is given. Fit a binomial distribution to this data and calculate the expected frequencies. Data is given in the table. Number of dice showing 1 or 3 or 5. The values are 0, 1, 2, 3, 4, 5. And observed frequencies are given 1, 10, 24, 35, 18 and 8. So using the given data, first we need to find the binomial probability distribution function, and later using that function find the expected frequencies. So solution, let small p the probability function. P be the probability of getting 1 or 3 or 5. Since there are 6 faces for the dice, so total number of outcomes will be 6, and so P is the probability of getting 1 or 3 or 5. So there are 3 odd faces and total number of faces are 6, so it is 3 by 6. So P will be 1 by 2. As you know, if P is 1 by 2, Q will be 1 by 2. Now here we denote X. Let X denote the number of times an odd number turning out. So P of X will be NCX P raised to X Q raised to N minus X is a binomial distribution. So where here N is what? N is 5 because the number of dice. Hence P of X becomes 5CX, and we know P as 1 by 2 raised to X. Q is also 1 by 2. N minus X, that is 5 minus X. So this is nothing but 5CX 1 by 2 raised to X into 1 by 2 raised to 5 into 2 raised to minus X. So 2 raised to plus X minus X will cancel. So your Px is nothing but 5CX, that is into 1 by 2 raised to 5. So this is what the required. This is the binomial probability distribution function. Once we get the function, we need to find the expected theoretical frequencies. So for that, first we need to find the function. That is, since we are throwing 5 dice 96 times, so expected frequencies are obtained from the function. That is, since 5 dice were thrown 96 times, so expected frequencies are obtained from f of x is equal to 96 into p of x, where x is equal to 0, 1, 2, 3, 4, 5. So consider f of x is equal to 96 into the probability function, that is 1 by 2 raised to 5 into 5cx. So this is 96 into 1 by 32 into 5cx. So this is 3 into 5cx. So hence, once we got the function, just go on substituting the values of x in the function. So that is f of 0 is 3 into 5c0 is 3. F of 1, 3 into 5c1. So this is 3 into 5 is equal to 15. And f of 2, 3 into 5c2, that is 3 into 10 equal to 30. F of 3, 3 into 5c3, that is 3 into 10 again 30. F of 4, that is 3 into 5c4, that is 3 into 5, so 15. F of 5, 3 into 5c5, that is 1, so it will be 3. Hence the expected means theoretical frequencies are 3, 15, 30, 30, 15, 3. So next example. Show that for a binomial distribution p of x plus 1 is equal to n minus x divided by x plus 1 into p of q into p by q into p of x. So to solve this, we use the definition of binomial distribution function. So we have the binomial distribution function that is given by p of x is equal to ncx p raised to x into q raised to n minus x. Start. Call this as equation 1. Now just I replace x by x plus 1. So p of x plus 1 is equal to n c x plus 1 p raised to x plus 1 q raised to n minus x plus 1. So as you know, n c x plus 1 is given by n factorial x plus 1 factorial into n minus x plus 1 factorial, simply the definition of combination NCR, into p raised to x plus 1 into q raised to n minus x plus 1. Now multiplying and dividing by n minus x in the RHS, we have p of x plus 1 is equal to, so n factorial n minus x divided by x plus 1 factorial can be written as x plus 1 into x factorial, and n minus x plus 1 can be written as n minus x into n minus x minus 1 factorial into p raised to x plus 1 into q raised to n minus x plus 1. So here I will write n minus x divided by x plus 1 separately into n factorial divided by x factorial into n minus x factorial. So in the above step we divided n minus x and n minus x minus, we open the bracket here, so n minus x minus 1 factorial. So n minus x into n minus x minus 1 factorial can be written as n minus x factorial. P raised to x plus 1 is written as p into p raised to x. Q raised to n minus x minus 1 can be written as q raised to n minus x minus 1 minus q raised to minus 1 can be written as divided by q. So this is equal to n minus x by x plus 1, this p and this q, so I write it as p by q. So we will left out with n factorial divided by x factorial into n minus x factorial into p raised to x into q raised to n minus x. So n minus x by x plus 1 into p by q, this is nothing but ncx into p raised to x into q raised to n minus x. Now by using equation 1 in the RHS, we have n minus x, so this LHS is p of x plus 1 by x plus 1 p by q. This ncx, p raised to x and q raised to n minus a according to equation 1 is p of x. So these are the problems on binomial distribution. In the next video we will solve examples on Poisson's distribution. Thank you.